Hi everybody, can you hear me? Okay. Uh, please confirm if you can hear me. Mm. Um, Good afternoon, everybody. Um, is it from my network or uh, okay? Mm, yes, you can hear.
Hello everybody. Welcome to this session. Please, Victor Jacobs, you can unmute your, please share your screen. Uh, so now we have a speaker, Victor Jacob, who is speaking. Please just share your screen, Victor. Okay, yeah, she's talking about decoding financial documents, preparing unstructured data for LLM application. So please, this session is for 45 minutes. We have 30 minutes. It's a workshop. We have 30 minutes for presentation, then 15 minutes for Q&A. Victor, please go ahead. The stage is yours.
Okay, thank you, everybody. Can you hear me? Bruno, please confirm if you can hear me. Bruno, can everybody hear me?
Yes, I can hear you.
All right, thank you very much. Okay, so um, without wasting any time, my name is Victor Jacob Asuquo, and I'll be taking you on decoding financial documents today. And I'm super excited here to share my knowledge and idea with you. As we proceed towards the session, you are going to learn more about me, and you are also going to understand how to process documents and make it ready for large language models. Okay. Yeah. So my name is Victor Jacob Supo, and I am a machine learning engineer at Start Innovation Hub. That is just a little bit about myself. about me, I also just the same way we have data community Africa. Few months ago, I started a community, a Python community here in Uyo, and also later I also started another community, TensorFlow, which is now machine learning. And I'm also Python to AI and machine learning network. Passionate about machine learning and multi-player. We are, we need people to collaborate with the project, um, people to join your team and reach out to me as well. To my, so, across this year, we have had a lot of bootcamps and sessions, both physical and virtual. And this is first image here is doing a Python makeup. The second one is doing an AI makeup with some virtual background. Yeah, so back to the business of today. Today we are going to look at the agenda for today. We are going to look at the introduction to RAGs, and then we are going to look at preprocessing documents. How do we preprocess documents? And we are going to look at extracting and normalizing documents. I'm going to look at the metadata and text. Just to extract, look at how we can extract and normalize contents. And then after doing all these things, what next? Okay. So from what we have here, we have what are large language models? Large language models are extremely large. You know that GPT of Gemini, of Bard, and you know so you know Bard, so what large language models do is that it tries to try to can you hear me? Like, can you hear me? Because I'm not able to hear. Can you hear me now? I'm speaking into my microphone now. Can you hear me? Okay. So I'll continue. So we are looking at large language models. What is the command? Yeah. Oh my God. We are looking at large language models. Large language models, they are the building blocks of everything we do. We use it every day for to they are they are like knowledge bank in sense that we want to, uh, if we really do questions like, let's say, can you generate content for me? Can you do me? Then you can use large language. Yes, yeah, large language try to connect. Right? Okay, can you hear me now?
Yes, you're audible. Yes, you're audible.
Okay, so I think this is better.
Yes, this is better.
Sorry, let me use my. I have to speak this way, so I mean that means I have to start all over. All right. So our agenda for today, we're looking at introduction to RAGs, how we can, what are retrieval augmented generation, what are they all about? We are also going to look at pre-processing documents. How can we pre-process financial documents for um so that we can use them with large language models. We are also going to look at how to extract and normalize document, and also we will look at metadata and search. So, and then after metadata and search, what next? That is what we are going to consider next. So, what are large language models? Like we all know, large language models are extremely large. They are trained on publicly made available data. So we use it every day for content generation, for you know, things like summary writing. And we can say, okay, generate this summary for me, or create this, give me a summary of this using a particular prompt template. We are going to look at that in this session. But if you look at how the structure of how large language model works, it tries to predict the possibility of a next word, or let me say a next text or embedding. So let's say we have something like the cat sat on the dash, right? It is what this base LLM does is that it tries to match out the word that most likely to be used next. So it predicts the next word. That is how large language models work. So if you can see here that the card starts on here, we have options like math, rock, J, and okay, we can say rock because the probability of rock in the next word is higher than math and J. So large language models are phenomena for knowledge generation and reasoning. They are pre-trained on large amount of publicly available data. So just like I explained data, large language models like ChatGPT, Gemini, they are good. They are very, very. I mean, so if we are looking at if we are looking at the capabilities of large language models, yes, they are extremely good for text generation, for summarization and questioning and answering tasks. So, for example, it, we can use it to ask questions. We can use it to. I mean, all of us, you know what? I don't have to spend time on explaining how large language models works. So next we have multimodality. So initially, remember when these large language models were launched, we only had like text to text, whereby you can send a text query and you get a text response. And we also have a situation whereby um if you send audio, you can get audio response. But currently, look at when Gemini was released, you can say that there's, there's what we call multimodality. Multimodality had been introduced. And what is multimodality? Multimodality means in where we can interact and work between different modes. So meaning you can send a text query and get a video response back, or a text um or audio response back. So you are now working in between modes. For example, you can send a text prompt and you get an image or back like what you can see here. A photo of a cat with bright galaxy filled eyes. So now but the introduction of multimodality brought problems because these are different modes, right? The way we work with audio is not actually the same way we work with text and videos or any other mode of data. But there's something common among all of them, which are embeddings. And looking at financial documents, I mean, if, if you look at a typical financial document contains a lot of things, right? It contains text, contains images, it contains video, it contains even PowerPoint. And and in that case, we can say that such documents are unstructured, meaning if you are working with only text, you might not be able to retrieve the information you need from images and from other forms of data. So let's say, for example, um, you are looking at getting a particular revenue that was generated in your bank, right? And you want to and the net worth is actually in an image, or maybe it's visualized, or the total sales is visualized in a dashboard. If you try to pass that document into any application or RAG or LLM, to not be able to access the information because it is not as text. So by the end of today, you are going to understand what retrieval augmented generation is, how we can use it with financial documents, and how we can not just use it but make sure that we pre-process both HTML, CSS, that is both the different forms of data that we can have financial documents, meaning that whether it's a PDF, whether it's a PowerPoint, whether it's an image or text, we can process them. That is, we can we can convert them into into modes that we can directly make queries and get responses from them. So talking about financial documents, look at every company is unique, and that's what sets every company apart. Let's take, for example, my company or your company. We both have financial documents. In fact, all companies have financial statements, but it is not the content is different, meaning that statement of account is different from every other statement of account, or let me just say financial document is different, but they are similar. So if you try to ask the large language model we have, things like how much did my company make, or try to integrate it to customer care service, we are going to have a problem known as hallucination. And hallucination comes about because the the this this large language model is not grounded with industry specific information, right? They are good for normal basic tasks, but looking at how we want to rank, looking at specific industry position, industry questions or query, our large language model does not have vital information needed. So there is a solution, and solution to this case is retrieval augmented generation. I know we might have heard of retrieval augmented generation many times. Maybe we have gone on a website, you have seen an ad, and you are like, okay, chat, do you know you can chat with your PDF? That is that is one of the use cases of retrieval augmented generation. Okay. So retrieval augmented generation is a technique for grounding LLM responses on validated external information. RAG apps load context into a database, then retrieve context to insert into a prompt. For industry use cases, relevant content come from diverse documents types such as PDF, Word docs, email, and web pages. Yeah, let's say the source of um your data source comes from different sources, just like explained. There must be a way we need to channel down these different sources into a way that we can interact with given our application or LLM code. So how retrieval augmented generation works is that you have your financial data, right? I'm just trying to explain how retrieval augmented generation architecture works. We have your financial data, and your financial data contains things like it contains both um text, it contains text elements, it contains metadata, it contains even HTML tags and some PowerPoint presentation. Then we can now chunk them. By chunking, I mean we are now looking at tokenization, breaking or group breaking down this because these documents are extremely large, right? And we cannot pass a whole query or a whole PDF or a whole document at once into your LLM application, right? So we have to break it into smaller chunks. By smaller chunks, I mean smaller units or embeddings or group of similar embeddings, such that we can use these chunks to work with our application. So we can now bring this financial document and then look at how we can break it into chunks and then store it as embeddings in a vector database or a giant database or a store. Then integrate it with a base LLM applications. So what happens is that each time you query, let's say for example, how much sales did my company make last year from the financial data, the query directly goes to your vector database, which is where the actual information is stored. And what is now retrieved is now sent to the base large language model. And here, at that from there, we can now have a response back to the user. So that is the architecture of retrieval augmented generation. So let's let's look at so the problem LLMs do not know your business proprietary data or domain-specific data. LLM do not have real-time information. Large language models find it challenging to provide accurate citations from their parametric to knowledge. And the solution, just like I explained, we feed the large language model that is relevant context in real time by using an information retrieval system. Right. So now here is where the problem comes in. You know that we have the finance at these documents we are looking at, they have different. Yeah. Is anybody speaking? Okay. So these documents we are looking at, they have different things. Sorry, what did you say?
I don't
Um,
think
You can
anybody
continue.
is
I don't think
speaking.
anybody is speaking. Please go ahead, please.
Okay. So here is the thing. The This document, right? Let me see if I can show you how a financial document looks like. So I'll just try as much as possible to be fast because the time is really, really short. I mean, 40 minutes cannot do everything. So here is the link to a code lab that click to get the resources and every other thing you need to be able to build your own. This link is built, this particular rack system is built on Vertex AI.